The Mythical Man-Month by Frederick P. Brooks, Jr. Picture this, a vast, sun-baked plain stretching endlessly before you. In the distance, what looks like a welcoming pool of water shimmers in the heat. A magnificent mammoth, exhausted and thirsty, spots it and lumbers forward, desperate for relief. But as its massive foot touches the surface, something's terribly wrong. This isn't water at all. It's tar, thick and sticky, gripping tighter with every movement. The mammoth thrashes, trying to escape, but every struggle just pulls it deeper. This powerful creature, built to survive almost anything, is slowly swallowed whole by something it never saw coming. Now here's the wild part. Frederick P. Brooks, Jr. tells us that this ancient tar pit is actually the perfect metaphor for modern software projects. For decades, brilliant teams backed by millions of dollars have found themselves stuck in exactly this kind of trap. They thrash around, miss their deadlines, blow through their budgets, and somehow end up with a product that's more mess than masterpiece. For years, everyone scratched their heads wondering why this kept happening. But Brooks, he knew. He'd been there, right in the thick of it, managing over 1,000 people on IBM's massive operating system /360 project. He stared into that tar pit himself and lived to tell about it. When he came out the other side, he wrote down everything he'd learned in a collection of essays that would become legendary. That collection became the Mythical Man-Month. Since 1975, this book has been quietly revolutionizing how people think about building complex things. And here's what's fascinating. It hasn't just been devoured by programmers. Architects, doctors, lawyers, and anyone who's ever tried to lead a team through something ambitious has found wisdom in these pages. Why? Because Brooks uncovered something profound. The real problems that sink big projects aren't about technology at all. They're about us, about how we communicate, how we organize ourselves, and about our stubborn habit of being way too optimistic about what we can pull off. Today, we're diving into the timeless wisdom of this book. And trust me, this isn't just for the tech crowd. By the time we're done, you'll understand the hidden forces that cause ambitious projects to collapse. Whether you're building an app, launching a startup, or just trying to survive a group project, you'll discover why throwing more people at a late project almost always makes things worse, not better. And you'll learn the one quality that separates elegant, beloved creations from clunky, frustrating disasters. Think of this as your survival guide for navigating the tar pits of creation. So let's start with the big question. Why do so many projects, stuffed with talented, hardworking people, go so spectacularly wrong? Brooks says our first mistake is how we think about work itself. We look at a massive project and imagine it's like harvesting wheat. If one person can harvest a field in 10 days, then obviously 10 people can knock it out in a day, right? We treat work like it's perfectly divisible. We even measure it that way. The man-month. A project needs 24 man-months, so we figure 2 people can finish it in a year, or 24 people in a month. But Brooks, with the gentle patience of someone who's watched this fail over and over, tells us this is a dangerous myth. It's the Mythical Man-Month. Building something complex isn't like harvesting wheat. It's like having a baby. 9 months is 9 months, no matter how many women you assign to the job. Some things simply can't be sped up by adding more hands. In fact, adding more hands often makes everything slower. This brings us to the book's most famous bombshell, now known as Brooks's Law. Adding manpower to a late software project makes it later. Stop and think about that for a second. It goes against every instinct a manager has. The project's behind schedule? Throw more people at it. But that's like trying to put out a fire by dumping gasoline on it. Brooks explains exactly why this backfires. Imagine 3 people working together. They have 3 communication channels between them. Simple enough. Now add just 2 more people. The team hasn't even doubled, but suddenly there are 10 communication channels. Everyone's spending more time in meetings, writing emails, and trying to stay in sync than actually working. And that's not even the worst part. The new people don't know the project. Someone has to train them. And who does that training? The experienced folks, who get pulled away from the very work that's already running late. It's a vicious cycle. The work gets reshuffled, which disrupts everything, and can even invalidate stuff that's already done. This is the gravitational pull of the tar pit. The more you struggle, the more you add resources, the deeper you sink. The project schedule slips one day at a time, so slowly you barely notice, until you look up and realize you're a year behind. So if throwing people at the problem isn't the answer, what is? This is where Brooks shifts from diagnosing problems to offering solutions. And his solution starts with completely rethinking how teams should work. He says we've been doing it all wrong. We think of teams like a hog butchering crew, where everyone has a knife and hacks away at the problem. This creates chaos, confusion, and a product that feels like it was designed by a committee, because it was. Instead, he proposes something he calls the surgical team. Picture a master surgeon in an operating room. She's the one doing the delicate, critical work. But she's surrounded by a team, and every single person in that room has one purpose: to support her. There's a co-pilot surgeon ready to assist or take over. There's an anesthesiologist, nurses, and technicians handling tools and equipment. They don't all try to perform surgery. They enable the surgeon to perform at her absolute best. Brooks argues this is how we should build complex systems. At the heart of the project should be a single mind, or at most a tiny unified team, acting as the chief programmer or architect. This person is the surgeon. They design the entire system, from the big picture down to the finest details. They write the critical code. They guard the vision. Everyone else? They're the support team. There's a co-pilot who acts as a sounding board and backup. An administrator handles budgets and personnel, freeing the architect from paperwork. An editor writes documentation. A toolsmith builds specialized tools. A tester relentlessly tries to break everything. With this model, you get the best of both worlds. You have the unified vision of a single mind, but the productivity of many hands. Communication gets radically simplified because everyone knows who to talk to. The surgeon is the hub. This leads us to what Brooks considers the single most important quality of any great design, whether it's software, a building, or a symphony. He calls it conceptual integrity. He tells the story of the great European cathedrals. Many were built over centuries by different generations of builders, and you can see it. A soaring Gothic section might be awkwardly attached to an older, sturdier Norman part. Each builder was tempted to improve the original design, to put their own stamp on it. The result is a mix of styles, a testament to many different artists' egos. But then Brooks points to the Cathedral of Reims in France. It, too, was built over generations, yet it stands in glorious unity. The guidebook explains why. For 8 generations, each builder sacrificed some of his own ideas so that the whole might remain pure. They stayed committed to a single, coherent vision. That, Brooks says, is conceptual integrity. A system should be the product of one mind, or a very small number of like-minded individuals. It's better to have a system that skips some features and fancy extras, but reflects a single set of design ideas, than to have a hodgepodge of good but uncoordinated ideas. This is a profoundly undemocratic idea when it comes to design. Design by committee, Brooks argues, kills conceptual integrity. It leads to what he calls, quote, featureitis, a system so bloated with features that it becomes slow, confusing, and painful to use. The architect isn't a dictator, though. They're a servant. They're the user's champion. Their job is to defend that clean, simple, coherent vision against the pressures of schedules, budgets, and committees. But even with a brilliant architect and a surgical team, there are hidden traps. One of the sneakiest is what Brooks calls the second system effect. He says the most dangerous system a person ever designs is their second one. The first system is usually spare and clean. The architect knows they don't know everything, so they're cautious. They have lots of clever ideas for features, but they wisely set them aside, thinking, I'll use those next time. Then, The first system succeeds. The architect is now confident, a proven master. They set out to build the second system. This is where danger strikes. They pull out all those stored-away ideas. They try to build the grand, feature-rich masterpiece they've been dreaming about. The result, as the ancient poet Ovid wrote, is a, quote, big pile. The system becomes over-engineered, complicated, and often fails. Brooks points to his own project, OS 360, as a prime example. The teams were full of brilliant people who'd each built one successful operating system before. OS/360 was their second. It was loaded with functionality, but it was also late, over budget, and took years to stabilize. For instance, the system had a routine using 26 bytes of precious memory just to handle December 31st on leap years. This, Brooks reflects, might have been better left to the human operator. The discipline to avoid the second system effect is awareness. The architect must be willing to assign a cost to every new feature, not just in dollars, but in complexity, memory, and performance. So how does an architect communicate this grand, unified vision to the hundreds of people who need to build it? This brings us to the story of another great, failed project, the Tower of Babel. The book of Genesis tells us that project had a clear mission, plenty of workers, and all the materials they needed. So why did it fail? It failed because of a communication breakdown. People could no longer understand each other. Work ground to a halt. This, Brooks says, is the reality of every large project. The left hand doesn't know what the right hand is doing. To fight this, you need relentless, multi-layered communication. You need informal chats, regular technical briefings, and most importantly, a formal project workbook. The workbook isn't just a pile of documents. It's the living heart of the project. It contains everything: objectives, specifications, technical standards, schedules. In the OS 360 project, this workbook grew to be 5 feet thick. Maintaining it became someone's full-time job. They eventually switched to microfiche, shrinking it to manageable size. Today, we'd use a shared online system, like a project wiki or shared drive. But the principle remains. All project knowledge must live in one central accessible place. Every decision, every change, must be documented and communicated. But Brooks also shares a crucial mistake he made. He faced a choice: have a small team of 10 architects write full specifications, taking 10 months, or let the 150 implementers help write them, promising to finish on schedule. Fearing the implementers would sit idle for 10 months, Brooks chose the second path. The result? The specifications were not only 3 months late, just as the architect predicted, but they were much lower quality. The lack of conceptual integrity, he estimates, added a full year to debugging time. It was a multi-million-dollar mistake, but a memorable one. He learned that it's dangerous to try keeping everyone busy all the time. Sometimes, the most productive thing an implementer can do is wait for a clear, solid design. This leads to one of the book's most counterintuitive yet vital pieces of advice: plan to throw one away. Chemical engineers learned long ago that you can't go straight from a lab experiment to a full-scale factory. There has to be an intermediate step, a pilot plant. The pilot plant is where you learn the hard lessons of scaling up. Brooks argues software is no different. In most projects, the first system you build is barely usable. It's too slow, too big, or too awkward. It is, in effect, a pilot plant. You're forced to start over, smarter but much later than planned. The management question isn't whether you'll build a pilot system. You will. The only question is whether you plan to build a throwaway, or whether you promise to deliver the throwaway to your customers. Delivering that first flawed system buys you time, but at a terrible cost. It creates agony for users, distracts your team with support while they're trying to redesign, and gives your product a bad reputation that's almost impossible to shake. So the advice is radical but clear: plan to throw one away, you will anyway. When the book was re-released for its 20th anniversary, Brooks revisited this idea. He realized plan to throw one away was too simplistic, because it assumed a linear process, the waterfall model. where you plan, then code, then test, then you're done. But building software isn't like that. It's a process of discovery. Users themselves don't truly know what they want until they see a working version. So a better approach isn't just building a throwaway prototype, but adopting an incremental build model. The idea is to start by building an end-to-end skeleton of the system. It might not do anything useful at first, except run without crashing. Then, function by function, you flesh it out. At every stage, you have a working, testable system. The effect on team morale is electric. There's a huge psychological boost when you see that first simple rectangle appear on the screen from your new graphics program. You always have a running system. This lets you get user feedback early and often. You aren't building a system, you're growing it. This is a profoundly different way of thinking. Instead of trying to build a perfect, monolithic cathedral from a flawless blueprint, you're planting a seed and nurturing it, letting it grow organically. As we near the end of our journey through this book, we arrive at its deepest philosophical insight, an idea from a later essay Brooks wrote called No Silver Bullet. He asks a fundamental question: why is building software so hard? And will it ever get easier? He looks at computer hardware history, which has seen almost magical, thousand-fold improvements every couple of decades. We keep waiting for a similar silver bullet for software, some new technology or management technique that will slay the werewolf of missed schedules and buggy products. Brooks's conclusion is sobering. He says there is no silver bullet, and there never will be. To understand why, he says we must divide software development difficulties into two categories: accidental difficulties and essential difficulties. Accidental difficulties are problems that come from our tools. In early days, these were immense. Programmers wrote in cryptic machine languages, waited hours or days for batch processing results, and worked with severe memory constraints. Over the years, we've made incredible progress solving these accidental problems. High-level languages, time-sharing, and powerful personal computers have swept away whole layers of this complexity, but the essential difficulty remains. The essence of software is crafting complex conceptual structures. It's the pure mental work of designing interlocking datasets, the relationships between them, and the algorithms that operate on them. This work is inherently difficult for 4 reasons. First is complexity. Software is more complex for its size than any other human creation. No two parts are alike. If they are, you make them into a single subroutine. This means, as a software system grows, its complexity explodes non-linearly. Second is conformity. Software must conform to messy, arbitrary, and often illogical human institutions and systems it serves. It has to adapt to interfaces designed by different people at different times. This complexity cannot be engineered away. Third is changeability. All successful software gets changed. It's used in new ways, adapted for new machines, and the world it operates in constantly evolves. Software is pure thought stuff, infinitely malleable, so it's constantly under pressure to change. And fourth is invisibility. Software is invisible and unvisualizable. A building has a floor plan. A computer has a schematic. But software doesn't have a natural spatial representation. We can draw flowcharts or structure graphs, but each only shows a single, one-dimensional shadow of a complex, multi-dimensional reality. The hard part of building software, Brooks concludes, isn't the labor of representing our ideas in code. The hard part is the specification, design, and testing of the conceptual construct itself. The bugs aren't in the syntax, they're in our thinking. And because this is the essence of the work, building software will always be hard. There's no silver bullet that can make the act of pure thought an order of magnitude easier. This might sound pessimistic, but Brooks insists it's not. It's realism. The hope for a magical solution is a distraction. Progress will be made not by a great leap, but by steady, disciplined, step-by-step improvement of our craft. It'll come from growing great designers, from buying instead of building, from rapid prototyping, and from growing software incrementally. There's no royal road, he tells us, but there is a road. As we step back from the rich, dense landscape of the Mythical Man-Month, What's the enduring lesson we can carry with us? It's been nearly 50 years since this book was first published, an eternity in the world of technology. The computers Brooks worked on are museum pieces now. The programming languages have evolved, and yet the core struggles he described feel like they were written yesterday. That's because this book was never really about software. It's about the timeless, deeply human challenge of creation. It's about how we, as fallible, optimistic beings, attempt to build complex, perfect things together. The tar pit isn't just a software problem. It's the nature of ambition itself. Anytime you gather people to build something that pushes boundaries, you're standing at the edge of that pit. The most powerful lesson for me is Brooks's humility. In a field obsessed with revolutionary breakthroughs and silver bullets, he gives us permission to acknowledge that this work is hard. The frustration, the delays, the tangled complexities, they're not signs that you're failing. They're signs that you're engaged in the difficult act of creation. His wisdom teaches us to shift our focus. Instead of searching for a magical tool that'll make work easy, we should focus on what truly matters: the clarity of our vision, the health of our team, and the discipline of our process. The problem isn't the code, it's the communication. The challenge isn't the machine, it's the management. So how can you apply this in your own life, starting today? Here are a few simple actions. First, for your very next group project, no matter how small, insist on appointing one person as the architect. This person's job isn't doing all the work, but being guardian of the final vision, ensuring every piece fits together into a coherent whole. This single act will bring surprising clarity and purpose to your team. Second, the next time a project you're on falls behind schedule, resist the instinct to just throw more people at the problem. Instead, pause and ask why it's late. As Brooks's law teaches us, the cure can often be worse than the disease. The real problem might be a flaw in the plan, a communication breakdown, or an unforeseen technical hurdle that more people will only complicate. And third, embrace the throwaway mindset in your own creative work. Whether you're writing an essay, creating art, or starting a new venture, build a simple, quick and dirty version first. A prototype. A first draft. Don't try to make it perfect. The goal is to make it real so you can learn from it. Then, with the wisdom you've gained, you can build it again, and build it right. In the end, the Mythical Man-Month is about the triumph of disciplined, humble craftsmanship over chaotic, prideful ambition. It reminds us that building great things isn't a sprint, it's a marathon. It's a journey requiring not just brilliance, but patience, communication, and deep respect for the inherent complexity of the task. The tar pit will always be there, but with the wisdom of Fred Brooks as our guide, we have a much better chance of navigating it. That was a summary of The Mythical Man-Month by Frederick P. Brooks, Jr. We've journeyed through the core ideas today, from the treacherous tar pits of project management to the elegant solution of the surgical team. But I want to be honest with you. A summary can only ever show you the map. The real adventure happens when you explore the territory yourself. The true power of this book is in the quiet moments of reflection, when one of Brooks's timeless stories connects with a problem you're facing right now. This summary is your starting point, a way to see if this classic holds the answers you're looking for. If anything we've discussed today has sparked your curiosity or shed light on a challenge in your own life, I encourage you to pick up a copy. Reading it isn't just about gaining knowledge. It's about absorbing a half-century of wisdom that can fundamentally change how you build, create, and lead. The link to the book is in the description below. Also, if you found this journey valuable, please take a moment to like this video and subscribe to the channel. Your support helps us continue exploring incredible books on the billionaire's bookshelf, bringing you the ideas that have shaped the world's most successful minds. Let's keep learning and growing together.